In today's video, we're going to look at section 5.4, which looks at the multiplication principle. This basically looks at counting the number of ways that something can be done. Okay. For every example that we're going to look at here, the tasks that we are looking at are split into different sections. So there will be a number of ways to complete the first task, a number of ways to complete the second task, etc. And then we want to know how many ways in total there are to complete the entire task that has been split up into multiple smaller tasks. So that's what we're going to look at here. The first example I'm going to look at is kind of a classic example when we look at the multiplication principle, and that is looking through a maze and how many ways we can actually get from one point to another through a maze. So let's say that we start at point A and there are 4 different paths that are going to get you to a point B. So I can take 4 different paths to get to the point B. And then to get from point B to point C, I'm going to have 3 different paths. And the question is, how many ways can I travel from A to C? Okay. How many possible ways are there to go from A to C? So we know that there are 4 different ways to travel from A to B and 3 different ways to travel from B to C. Let's assume that I took this first path. I'm going to label it in blue here. I took that first path to get from A to B. Once I've got to B on that first path, I can then choose any one of my 3 paths to get from B to C, and each one of those is a unique way of getting from B to C. So by taking that first path, I get 3 different ways that I can travel from A to C. Okay, I can take the first path from A to B and then the first path from B to C. I can take the first path from A to B and the second path from B to C, or I can take that first path from A to B and then the third path from B to C. So that gives me 3 different ways of getting from A to C. Same goes with the second path from A to B. When I take that second path from A to B, I then have 3 different ways of getting from B to C for that second path from A to B. Okay? You can do this for each one of your 4 paths going from A to B. And you find that for each one, there are 3 different ways of getting from A to C. I take my first path from A to B, and then I've got 3 options of getting from B to C. I take my second path from A to B, I've got 3 different options of getting from B to C, etc. So that means that I have 4 times 3 different ways of getting from A to C. My advice to you with this would be always draw out the problem that they give you. So if they tell you that there are 4 different paths from A to B and 3 different paths from B to C, go ahead and draw it out, because then you can actually see for yourself exactly the possibilities that you have. Okay? So we can see that we have 4 different paths from A to B and 3 different paths from B to C, and you can actually trace out all 12 possible paths that you could take, whether you took the first path from A to B and the first path from B to C, or I could take the third path from A to B and then the first path from B to C, okay? You can track out all of these 12 different ways of going from A to C. So I would highly recommend, just to kind of see what's going on, to go ahead and draw the graph. You can also do something called a tree diagram for these problems. So let me go ahead and draw this for you. So let's say you start at point A. I then know I have 4 possible ways of getting from A to the point B. Okay, And then for each one of my 4 possible ways, I then have 3 different ways of getting from B to C. So here is where you can see those 12 possible paths of getting from A to C. So this is called a tree diagram. So whenever you get a problem like this, you can either just go ahead and draw it like I did in my first example here, or you can go ahead and actually draw a tree diagram for it to see the number of possible ways. This brings us to the multiplication principle. Okay, and that says that suppose that a task is composed of 2 different choices. So a task is composed of 2 different choices. Okay. Okay, exactly like what we had in our previous example. We had the choice of how to get from A to B, and we had the choice of how to get from B to C. If the first choice can be performed in M ways, and the second choice in N ways, then the whole task can be completed in M times N ways. Okay. So exactly like in our example, we had 4 ways of performing our first task of getting from A to B, and we had 4 ways, or 3 ways, sorry, of completing our second task of going from B to C. So there were 12 possible ways of completing the whole task of going from A to C. We can actually generalize this for if you have more than 2 choices to make for a particular task, and that is called the generalized multiplication principle. Okay, so suppose that a task consists of T different choices, and again they're performed consecutively exactly as we did in our first example, where we had the first choice of going from A to B, and then right after that you would go from B to C to complete the whole task. Okay. Then suppose that for choice 1 there are going to be M1 ways to complete that particular task that we have at the start. Then choice 2 is going to have M2 different ways, all the way down to choice T, which is going to have MT different ways. Okay. Then the whole task as M1, M2 times MT ways of being completed. So this is just an extension of what we did before. If I had, let's say, an additional point that I wanted to add here, so if instead I added in another point D that I wanted to get to that had, let's say, 5 different ways of getting from C to D, then I would have done 4 times 3 times 5 to give me 60 ways of getting from A to D. So you just do it, you've got these smaller tasks that are performed consecutively to give you the number of ways that you can then complete the entire task. There's a couple other examples that I want to go through that will then lead us to something called factorials, which is the end of this section. So what I want to look at now is, this is again is a very typical example that you'll see, and this comes from the textbook, and it looks at, let's say you've got this corporation and they've got a board of directors with 10 members. So you've got this board of directors with 10 members on the board. Okay. Within that board, I need to select a chairperson. I also need to select a vice chairperson. And I need to select a secretary from those 10 members. And the question is, in how many ways can this be done? It doesn't really matter in this case which one you start with. We'll start with selecting a chairperson and work our way down from that, but it doesn't really matter in this particular situation which one you want to start with. Let's start with selecting a chairperson, okay? So we've got this board of directors that has 10 members on it. Any one of those 10 people could be the chairperson, okay? So we have 10 different possibilities for the chairperson from the board of directors. So for our first one, there are 10 ways of picking the chairperson, any one of our 10 members on the board of directors. For the vice chairperson, I've already picked my chairperson now. I've now got to pick the vice chairperson. Well, I've already got one person out of the running for that particular position because that chairperson can't take on both positions. So the chairperson is out and I have 9 possible people that could be the vice chairperson. So there are now 9 ways of picking the vice chairperson. Next, I have to pick the secretary. Well, again, I've picked my chairperson, I've picked the vice chairperson. I now have to pick the secretary, but the first 2 people that got picked for the chairperson and the vice chairperson are out. They cannot be the secretary as well. So that leaves me with 8 possible people that could be the secretary. So the number of ways that I can choose these 3 positions, the chairperson, vice chairperson and secretary, would be 10 times 9 times 8, which gives me 720 possible ways that I could select those 3 people. So there are 720 possibilities out of the 10 board of director members that I can have for my chairperson, vice chairperson and secretary. There are 720 different possibilities for picking those 3 people. Another problem that is kind of a standard problem that you get when it comes to looking at the number of ways that you can do something is always looking at either posing for a picture or lining up, and how many ways that people could do that, depending on the number of people that there are. Again, this comes from the textbook, and it's a common problem that you'll see in your homeworks, and it will come up in tests, etc., and it comes up in everyday life. And it's the number of ways that you could arrange a certain number of people in a photo, or the number of ways that a certain number of people could line up depending on their order. Okay. In this particular example, they've got a baseball team of 9 people. So you've got a baseball team of 9 people. How many possible ways can they arrange themselves to line up for a group picture? This kind of follows the same as what we did in our previous example. What I would do in this case, like I said with the first one, is draw it out. Okay. If you've got 9 people lining up, okay, we've got our 9 people lining up for this group photo, and these are each of the positions that they can stand in. Start with the first position, like we did with the chairperson. We started with the chairperson and selecting them, and then worked to the vice chairperson and then the secretary. We'll start with the first position in the photo, but it doesn't really matter which one you pick, but we'll start with the first one. In that first position, any one of my 9 players can stand in that position, giving me 9 different possibilities for people that can stand in that one position. For my next position, okay, someone's already standing in my first position. So now I'm left with 8 of the players that could possibly stand in my next position, okay? First person has already been stood in that first position, so they are out of the running to stand in the second position, leaving me with 8 of the players that can stand in that second place. You work your way down. We've now got 2 players already standing in their positions. So now for my third position, I have 7 of the players left that could possibly stand there. Now I've got 3 of my players standing in position, leaving me with 6 possible players that could stand in the fourth position, and you carry on in this way. And for your very last position, you're only left with 1 player, because all of the 8 other players are now in position, so there is only 1 possibility left, that last player to stand in that last position. So now when we look at how many ways this can be done to arrange themselves, we just multiply all of these numbers together, which if you type that into a calculator, which I would highly recommend, comes out with 362,880. So that's the number of possible ways that 9 people can line up in different arrangements, okay, depending on which player you pick to go in the first position. You then pick another player that could go in the first position, another player that could go in the first position, but each time you change that, you could also change the other players in their positions, and there's actually 362,880 ways that you could arrange 9 players in a line. Okay. In this example, you'll see that we ended up multiplying 9 by every number that goes before it. That can actually be kind of shortened into a shorter notation, and that is called the factorial. Okay, so if n is a positive integer, then n factorial is actually denoted by n with an exclamation point after it. N factorial is defined as n multiplied by n minus 1 multiplied by n minus 2 all the way down to 1. Okay. So we just take that number n and we multiply it by every number that goes before it down to 1. Just as kind of, this is kind of standard. You will probably never have to deal with this, but just so that you know, for 0 factorial, they don't actually say it's 0. They actually say it's 1. This is just kind of a standard, and the way that it's defined in mathematics, because you don't have any number before 0, and we don't use 0 in our multiplication in factorials, because if you multiply the entire thing by 0, you'd end up with 0. It's just kind of a definition that they add in as 0 factorial being 1. I would highly recommend you go ahead and go back to the previous examples that we have looked at, particularly the ones where you are given a certain number of people and they ask you to pick 3, 4, 5 people from that particular group, and the number of ways that you can do that. That's a very common problem. And also looking at the pathways example, because that is another very common problem. One last thing that I will look at, and again, very common problem. They've got an example that is very much like this in your textbook, and it's a very common problem, and it's license plates, and it's the number of ways that you can have a particular license plate. Let's say that your license plate for a particular state is going to be 2 letters and then 4 digits. Okay, so your license plate is going to be 2 letters followed by 4 digits. Okay. Sometimes they will say, okay, a particular letter is not allowed, in which case you've got to eliminate that from the 26 letters, or they'll say a particular number like 0 is not allowed. You'll have to take that out so that you're only left with 9 digits rather than 10. So just kind of keep that in mind. But for this example, I'll say that all letters are allowed, all numbers are allowed, and we are allowed multiples of a particular letter or number. Okay, that's another common one where they'll say, okay, if you've used a particular letter once, you then can't use it again. So in this particular example, there'd be 26 possible letters that could be used for my first letter, but then I would have to take that letter out and say that there's only 25 possibilities for my second letter. So kind of keep that in mind whenever you do these examples. That is another common thing that comes up. But right now, I'm going to say all letters are allowed. We can have multiples of letters. That's totally fine. So if I had a T followed by a T in my license plate, that's totally fine. And I'm allowed all 10 digits for my 4 possible digits here. So I can have anything 0, 1, 2, all the way through 9 is allowed. And again, I'm allowed multiples of those. How many license plates can I have? Like I said, you'll have to kind of make sure when you do this that you take into account what letters are allowed, what numbers are allowed, etc. So please keep that in mind when you do these examples. But in our case, there's 26 possibilities for the first letter. Like I said, we're allowed multiples of letters. There's no exclusions on the letters, so there's 26 possibilities for the second letter. And then there's 10 possibilities for the first digit, 10 possibilities for the second digit, etc. Okay, and again, all numbers are allowed here. We're allowed multiples of numbers, etc. If you multiply all of that together, you end up with 6,760,000 different license plates that are possible with this particular set of letters and numbers. So like I said, this is a very common example. Just keep in mind what letters are allowed. Are you allowed multiples of letters? And same with the digits. Go back and look through these examples and make sure that you're comfortable with them, and then go and try out the homeworks.